So welcome students. In this question you're given that this line lies completely on this plane. If that is so, what are the values of A and B, alpha and beta? So you have a plane, and you're given a line, and it's given that this line lies completely on this plane. So what are the conditions? So what are the properties of this line? This line is passing through the point 2, 1, minus 2. 2, 1, minus 2. And having DRs 3, minus 5 and 2. And what are the properties of this plane? The normal of this plane has DRs. The normal of this plane has DRs 1, 3 and minus alpha, the coefficients of x, y, z. Now, if this is the situation, so what are the conditions that need to be satisfied if this line lies completely on this plane? So I'll write two conditions because I need two unknowns. The first condition is that this point has to lie on this plane. Because this point lies on this line lies on this plane. This point has to lie on this plane. That means let us satisfy this. So 2 plus 3 plus 2 alpha plus beta is equal to 0. So this implies 2 alpha plus beta plus 5 is equal to 0. So this is one of the conditions that alpha and beta has to satisfy. So if you go to the next condition, the DRs of this line lies on this plane. So this line has to be perpendicular to the normal. So the DRs of this line and the DRs of this normal have to be perpendicular to each other. That means the dot product of these two have to be equal to 0. So let us do the dot product of these two. So 3 minus 15 minus 2 alpha is equal to 0. So 2 alpha is equal to minus 12. Alpha is equal to minus 6. Alpha is equal to minus 6. So once you get alpha is equal to minus 6, I'll substitute it here. So minus 12 plus 5 plus beta is equal to 0 and beta is equal to 7. So alpha beta is nothing but minus 6 and 7. That's the answer to this question. Thank you.